Welcome to my channel today. Today we want to talk about the change of base of logarithms. Okay, sometimes it is really useful to change the base of a logarithmic function in order to solve it. So that is the main reason why we have this particular video. Okay, so now if you have log, all right, log a to the base b, and for some reason, I mean, you are maybe experiencing some challenges in your solution, so you want to change the base from b to let's say a base called c. What you want to do is that you take log a, all right, log a to the new base that you want, that's base c in this example, divided by, all right, log b, all right, to the new base that you've chosen in this example, base c. So for example, if I have log 2 base 3 and I want to change this particular logarithm to be something in the base, say 5, then I'm going to have log, all right, 2 base 5 divided by log 3 base 5. So basically that is what this rule is trying to say, that if you don't like the base, you can change it and write it in this particular form. All right, now how do we apply this knowledge to problems? Let's consider the first problem that we have for the day. It says that given that, okay, given that u is equal to, let's highlight it, u is equal to log s base 4, find in the simplest form in terms of u. Now we have the first case. Let me divide this. All right, we have the first case as log 4 base 4. So if I have log 4 base 4, how do I manipulate this particular thing to look like log x base 4 so that I can put u in my solution, because they said it should be in terms of what? Of u. All right, so this is how we go about it. Well, if you consider what we have is in base what? X, but u actually is something in base 4. So change everything to base 4. Let's do that. So that means that we will have log 4 base 4 over log x base 4. All right, now there is a rule in logarithm that says the log of a value to the same base is 1. Therefore, we are going to have 1 over log x base 4. But ask yourself, what is log x base 4? Well, this log x base 4, it is the definition of u. So right now we can say that this is the same as 1 over u. All right, how about this particular one? Well, we have this case is also having the base to be what? X instead of base 4. All right, so let's just change the base. Let's make it base 4 and see if we can do something in relation to u. So log 16 base x will now become log 16 base 4. Okay, I'm changing everything to base 4 because the definition of u has base 4. Then I have log x base 4. Okay, now well, log 16 base 4 can be further simplified because you know 16 is 4 squared. So you now have log 4 squared base 4 over, check this thing out, log x base 4 is the definition of u. So that is u. So we can just put u here. Then this is going to give us 2 log 4 base 4 over u, and we have already made assertion that the log of a value to the same base is 1. So our answer is 2 over u. Okay, All right, my u is disgusting. Let me write it again. Over u. Okay, this is cool. All right, how about when we have something like this? Remember, let me just write the definition of a u here so that we don't have to go back and forth. Okay, so we have log 2 base x. How do we fix this? Well, log 2 base x is base x, but the definition of u is base 4. So let's change everything to base 4. That is log 2 base 4 over log x base 4. All right. So this is now going to be log 2 base 4 over u. All right. Log 2 base 4 is something that we cannot do anything about. So we will leave it like that. Okay. If it is something that we can actually simplify, then we would simplify. All right. But depending on your knowledge in log, you may leave it like this, or okay, since we are on YouTube learning, we are not in classroom, time is not something that is going to constrain us. So why don't we see something really nice here? Okay, you'll be tempted to leave your answer in this way, but let's explore small. Log 2 base 4. Log 2 base 4, we can change the base to maybe 2, okay, to see what happens. So if I do another change of base to base 2, I'm going to get log 2 base 2 over log 4 base 2. All right, but log 2 base 2 will become 1. And now log 4 base 2, 4 itself is 2 squared. So I'm going to have log 2 square base 2. Okay, going to give me 1 over 2 log 2 base 2. And I know 2 base 2 is what? It's 1. Therefore, my answer itself is half. Okay? So, that is, if you really want to simplify to the simplified form, then you can really say that this is half over u. Now, half over u, if you think it will confuse you, just write half divided by u. And that will give you half times 1 over u, giving you 1 over 2u. Okay, so that is the correct, this most simplified answer. Okay. All right, now let me clean this and then let's talk about this particular guy right in front of us. All right, so in this case, we have 8 log 8x. So we have log 8 base x. So let's change that to base 4, okay? Since the u definition is in base 4. So we have log 8 base 4, all right, over log x base 4. But we know log x base 4 is u. So now, that begs the question, how about the log 8 base 4? If you have log 8 base 4, can we do something about it? Well, the answer is yes, you can do something about it. Or most likely, if you don't know what to do about it, then it means that you are going to leave your answer in this form, okay? I'm not going to say that when you leave your answer in this particular form, what you've done is totally wrong. It's not. However, there's something that we can do about this particular thing. If you have, let's explore here. If you have log 8 base 4, you can change everything to base 2, okay? Because both 4 and 8 are multiples of 2, and it's easier that way, okay? Instead of changing everything to base 4, all right? Okay, so that means that I'm going to get log 8 base 2 over log 4 base 2. Now 8 is 2 cubed, right? So 2 to the power 3, and then base 2, then 4 is also 2 square. So now this is going to give me 3 log 2 base 2 over 2 log 2 base 2. Now these guys will cancel out, so your answer is 3 over 2, okay? Therefore, this is 3 over 2 divided by u. That is going to give you 3 over 2u. Okay, so that is what the answer is supposed to be when you simplify it to the lowest possible form. Okay, All right, let's move on. Now it says, given that this particular definition, okay, let's highlight it. This means 20, and this means 5. What do they want? They said that find this guy. All right, so they want us to find log x base what? Y. The question is, do we know x? Nope, we do not. So we have to find x. So from the definition, log x base p is equal to 20, we can say that x is 20 to the power, p to the power 20, okay? Now, from this definition, log y base p is equal to 5, we can also say that y is equal to p to the power 5, right? Good. So now we know what x is, we know what p is, we know what x is, we know what y is, so we can now work with our dear friend here. So that is log x, right? But we know x is 20 to the p to the power 20, and then y is p to the power 5. All right. Okay. So if we have this particular situation, what do? Well, the issue is not as simple as that. Why don't we just change the base? Because p to the power 20 and p to the power 5, you can't just work with it. So this is why we learn change of base, because like there's nowhere else to go. All right. So if we are going to change the base, then we can take base, maybe base p. It will be easy, or you can also make it base 10. Whatever you want to choose is fine. Okay. So let's see. Let's explore. Let me start with base 10. Okay. So if I have log, if you write log on its own, it's automatically in base 10. Okay. So if I have log p to the power 20 divided by log p to the power 5, then we can apply the law. So we have 20 log p over 5 log p. All right, so log p cancel log p, 20 divided by 5, that gives us 4. Okay, so that is the solution to this particular thing. Well, someone could say, okay, I don't want to use base 10, I want to use base p. Well, you are allowed to use that. Since everything is in p, you can still use base p and it will work out. Let's see how that will turn out to be. If you have log p to the power 20 log this guy, then you can take the base, instead of the base to be p to the power 5, we're just using the base as what? P. So you have log p to the power 20 base p over log p to the power 5 base p, and that will give you 20 log p to the base p over 5 log p base p, right? Now, they cancel out, or you can just say that p log p to the base p is 1, so you still come back to 4. So like I said earlier, this is one of the main reasons why we want to change the base, because sometimes there's a stumbling block, and then change of base makes it easier for us to continue solving our logarithmic equation. All right, so now let's move on to this particular one. This is a beautiful question. However, whenever you are given a logarithmic equation, the first thing I want you to check out is the bases. This is base 4, this is base 7, this is base 3. Bad news. Okay, different bases. Therefore, my friends, take your time, breathe in, and then figure it out. What base do you want to stick with? That's the first question you want to ask yourself. Maybe I want to stick with base 4. Then it means that this base 7, I want to change it to base 4. This base 3, I want to change it to base what? Base 4. Okay? Maybe I want to stick with base 7. So it means these ones, I need to get rid of them. That is how to work. However, you, before you even think of the basis, okay, also see if you can simplify the argument before you even think of changing the base. Well, I think we can simplify the argument, because if you look at 3 and 27, they have something in common. So that is good. If you look at 4 and 2, they have something in common. That is also good. So maybe you don't see what I see. So let's work it out. You know, I can reverse this 2 to come back. So that would become log 2 square base 4, right? Plus log 2x plus 3 base 7 is equal to log. Now, this 27 is 3 to the power 3, right? Base 3. Okay, cool. Now, let's see what happens. This will give us log 4 base 4 plus log 2x plus 3 base 7. And this is going to give us 3 log 3 base 3. All right. So this, sorry, this particular one will give us 1, because 4 log 4 base 4 is 1. Then we will keep this one here as log 2x plus 3, all right, base 7. Then we'll keep this. Now check this thing out. The answer is only 3, because you have 3 times 1. Okay. Now we are going to get log 2x plus 3, okay, base 7 is equal to 3 minus 1, giving us log 2x plus 3 base 7 is equal to 2. Okay, now there are 2 ways to solve this. You can decide to make sure that this 2 is something to the base 7, okay? That means that you can just call it log 7 base 7. It is allowed in maths. Or if you think this is maybe too complicated, then what you can do is also, let me just clean this guy here, right here. You can also write this, that 2x plus 3 is equal to 7 square, okay? Always the value down here comes to carry the value here, okay? So 7 square. Well, once you write it in this form, I mean, it's something that you can work with, okay? Because you're going to have 2x is equal to 49 minus 3, giving you 2x is equal to 46. So 46, that's 23, right? Okay, and you are good to go. Now, the earlier approach that I was talking about, okay, from here, I want to show you how to use that as well. So let's say you have log 2x plus 3 base 7 is equal to 2. I told you that you can also write log 7 base 7. You are using 7 because the base here is 7. All right. Now, that would mean that you have log 2x plus 3 base 7 is equal to log 7 square base 7. And that would definitely, you can see that, well, log 7 and log 7 will cancel out. So you have 2x plus 3 is equal to 7 square. And ladies and gentlemen, this particular argument that we have here is what we got there. All right. So, I mean, there are options. There are options in add maths and maths in general. You don't have to stick to one thing, okay? All right. So from here, I mean, I know you can solve for x and you are going to get the same 23. So let's move on. In this story, we have 2 things that we need to take care of. First, we have the I, and then we have II. All right. It says express, let me highlight it, express this guy in terms of this guy. Well, what does that really mean? They want us to manipulate what we have here in such a way that we are going to get log x base 2 from this. Well, you know, when you have log, so solution. So when you have log x base 4. I mean, it's just crazy. How do I get log x base 2 from here? So that's the problem. However, due to the power of changing of the base, we can just say that, well, what they have given us is in terms of base 2. Okay, so let's go and change everything here to base 2. And what would we get? Okay, it's exploration. Why not? It doesn't hurt to give it a try. So we are going to have log x base 2 over log 4 base 2. Okay, so now we have log x base 2. Now log 4 base 2 is actually 2, right? So we have indeed expressed what they gave us, okay, in terms of log x base 2. Well, if we have been able to do this, it says using your answer in part I and the substitution this. So now they want us, let me highlight that, it's really important. Let's maybe highlight that in red. All right, so this particular definition is really important. We're going to use it. They are telling us to solve this particular equation that we see right here. Okay, so let's solve it. Well, so excuse me, let me write it again. We have log for x base 4 plus log x base 2 is equal to 12. Well, now check something out. This particular log x base 4 is what we worked here, and we got this from there. So let's just put it there. That this is log x base 2 over 2 plus log x base 2 is equal to 12. I can just decide to multiply through by 2, and that will give me log x base 2 plus 2 log x base 2 is equal to 24, right? Well, if we go back to the question, they said that use this particular substitution. Okay, if you see log x base 2, call it u. So let's go and call it u. All right, so that would mean that we can call this particular guy u. We can call this to u. Okay, so we are going to have u plus what do we get? Hold on there. Right, there's something that we need to finish before that. Keep this one there. This 2 has to go back. So we have log x squared base 2 is equal to 24. If I do this, what can we do? Well, it wouldn't really work because we cannot call this u, right? We can't call it u squared. Okay, so I'll just clean it. I was trying to see if something will work out for us, but clearly it doesn't work. All right, because what you actually have here is check this now. You have log x base 2, then 2 log x base 2. So that is in itself is like 3. Okay, that's 3 log x base 2 is equal to 24. I wanted to see if there could be some smart way to do the thing, but it doesn't work, so sorry. Well, we are told that this particular thing is u, so we are going to get 3u is equal to 24. 24 by 3, what is that? Is it what? 6, 7? What is that? 8. Okay. All right, but you are solving it. Okay, they said solve. So this is not the answer. No. Okay, so you go back to state that but u is log what was the substitution? That's log x to the base 2. Okay, so that's what u is. Therefore, you can say that log x base 2 is equal to 8 because you found u to be 8. Then x is definitely going to be 2 to the power 8. And 2 to the power 8, let me use the calculator to do it. 2 to the power 8. Calculator says the answer is 256. All right. So that's how to go about this particular question. let's recap to see how we went about it. We saw that this particular argument, we got this from there, so that is what we use the substitution. We multiply through by 2, then we added this to that. After that, we did the u substitution. We found u, but we said that log x base 2 is u, so from there we got here. All right. So in our next video, I'll be talking about the natural log, okay, or the natural logarithms. Why do we call them the natural logarithms, and what are the properties of natural logarithms that we need to know and then apply to questions? So that is what we will discuss in our next video. So we'll meet again. Stay safe.